So thank you for the introduction and also for being here this early in the morning after the 10K run and everything. Today we are going to show you how to break a lot of the barriers in the satellite messaging on iOS. My name is Jiska and
I'm Alex.
I'm working at Hasso-Plattner Institute in Potsdam
and I work at CIMO, so same as Niels yesterday, and I'm a PhD student there. Yeah.
So for those of you who don't use the satellite messaging every day, we will have a short recap on all the features. So the first feature they introduced is emergency SOS. And the idea is that when you're off the grid, you don't have a Wi-Fi connection, and you try to make an emergency call, but that failed, you will be presented with a UI to bootstrap some communication with first responders in a very efficient format. The next feature they added is Find My over satellite, where you can share your location every 15 minutes with your friends. Same conditions apply, no Wi-Fi, no cellular coverage, but at least no failed emergency call, which is a bit of an advantage for us as researchers because we don't want to cause any false alarms to first responders. These two features were the first two launched in iOS 16.1, and then in iOS 17 they decided to enhance all of this emergency SOS with something that is implementation-wise super similar, but with another backend for roadside assistance. So when you and your car are stuck somewhere and you need some help and don't have any cellular coverage, you could get some help via satellite. But this is an US-only feature because it needs the collaboration of a company that helps you. And here in Germany, for example, that would be ADAC, and there's no such collaboration. The latest feature added, again, US only, is text messaging. So this is going to be in iOS 18. You can see me here texting with Christine, who is in the US, so I already tried the feature. And again, no Wi-Fi or cellular coverage is a precondition. The other precondition is the person you're texting with needs to be on iOS 18. I think they also need to be in the US, so there's lots of regional restrictions. And for SMS, it's even more complex. Like, you can send SMS over satellite, but then your network provider needs to forward this, and at least my network provider here in Germany doesn't, so I cannot really test the feature. So this is a lot of stuff implemented. There is one more thing that everyone can try anytime, which is a demo mode. And this demo mode helps you to make yourself familiar, because this whole UI is not super easy to use. And imagine yourself being in an emergency situation and the first time being presented with this UI, this might overwhelm you. So they decided to add a demo mode as well. But the demo mode does not actively send anything over the air. It just sends us where satellites are, so you have an idea of how you would get a connection to a satellite, but you cannot really use it for any security research. All of this communication is based on the Globalstar satellite network, so you have some satellites orbiting Earth, and also ground stations, and those ground stations can send something to those satellites, and they can send it or reflect it to the ground station. So they don't really modify the signal in a way, but they are more like mirrors in space and forward the same signal to a ground station. The overall network looks like this. You send, for example, your Find My location to a satellite, and then the satellite reflects that to a ground station. The ground station is connected to some Apple server, and that in turn sends it to an iPhone, which is connected to the internet, and this can receive the message. Just for all the terms that we are using. Apple has two other internal terms that we will be using in this presentation. They call the satellite a target and the ground station an anchor, because you are targeting this satellite and then get the reflection. And for the communication, it's essential that the satellite is in reach of both you as a sender, but also the ground station as it's just reflecting the signal. From iOS, you can also extract a map of the Globalstar services currently used by Apple. So you can see the ground stations in use. You can also see the supported countries, even though I think like on the very top of Canada, there's not really coverage. I just marked the whole countries if they are supported or not. And the red dots are some radio exclusion zones, so they don't want you to send everywhere to not disrupt any other services. And you can see there's even ground stations in use in countries that don't have satellite support yet. And the Globalstar infrastructure is even larger than this, so Apple doesn't use all of it, it's just the portion that Apple is currently using. And with this, we will dive into more technical details, which is the Find My Location sharing.
Yeah, so we are always interested in wireless research, and sending your location over a satellite connection is something new that hasn't been possible before, so we wanted to know how it works. So before I can tell you how the satellite connection and the sharing of your location works, I want to tell you how does Find My Location sharing work in general, because also that has not been really documented in public before. So first, when you are sharing or requesting a friend's location, you set up a connection to an Apple server, you just send a request, and that request is forwarded over Apple's push notifications to the iPhone of your friend. Of course, your friend can have multiple devices, but there's only always one device which is responsible for sharing your location. Normally it's your iPhone or your Apple Watch. And that iPhone then receives this, can you please send me your current location over a push notification, and then starts getting location updates and shares them back to the Apple server, where the Apple server can then start forwarding these also as push notifications back to your device. So then you can see where your friend is, and you also have live updates, so you can see when they are moving, if they're in a car, or if you're trying to find someone who's moving around in the city. That would work as well with the live updates. And all this happens while the friend's phone can be off, turned off, like not really turned off, but in standby in the pocket. Yeah, but Apple has also added end-to-end encryption, which is nice. So every time you share your location with one of your friends, you have one key, which is called key for sharing location with friends, or friends key. And that key is a public-private key pair that's sitting on your iPhone, and it's shared over a secure channel similar to iMessage to your friend's iPhone, so they can then use this private key to decrypt your encrypted locations. So every time you have one location, you use your iPhone uses ECIES encryption, which is a defined standard, and based on elliptic curves, and then in the end an AES symmetric encryption to get the encrypted location. If you're really curious which exact ECIES method is used, I've written it down here, but it's a pretty standard combination. So now we want to talk about satellite location sharing, since we now know how it generally works. In the same way, Apple didn't want to weaken your security of your locations that are shared when they are shared over satellite. But still, how can you make a connection to a satellite so that the satellite knows which device is connected to it, or like the ground station better than the satellite, and who is going to share this location, so that the friends can also see your location, not someone else's location. For this, Apple uses so-called LLC keys. They also have some other names, like transport keys, for example, but most times they're called LLC keys, and they are generated on your phone. It's a public key in your secure enclave, so this key cannot be extracted at all. You can only get a public key or perform some operations on the key, like a key exchange, for example. And that will be done, so you get the public key out of your phone. Your phone generates 30 of these keys, and one key is marked as last resort. So when all of the 30 keys are used up, the last resort key can always be used to continue satellite communication. So then Apple needs to know what are the keys that you have. So there's an API where your iPhone just shares all the public keys back to Apple, and Apple generates one server key for each of your public keys. So these server keys are then stored at Apple's side and also sent back to your iPhone. But only the public key, since the private key can just rest in Apple's database. And in the end, this can then form a key exchange on your phone. So you have, even when your phone is offline and doesn't have any internet connection, you have your private key in your secure enclave, and you have the public key from Apple also stored in your keychain. And these two keys are then can be used to create a secure shared secret, which is called a session key, and that will be used to initiate a satellite communication. So when the iPhone wants to talk to the satellite, you could think maybe there is a special chip that Apple has added to the iPhone that does satellite communication. For sure they have added a special antenna, but the chip is actually just the same iPhone baseband modem, so the Qualcomm modem does all the communication with satellites, and to initiate the satellite communication, the session key will be shared, and also the identifier from which LLC key this has been generated, and also your encrypted location. It all goes to the baseband, and then the baseband just handles all the satellite communication. So it connects to the satellite, which then mirrors back to the ground station. Then your location is stored. It's still the same encrypted location. It's a bit more packed, so it's using less data, but your friend can still see where you are, even though you don't have an internet connection. And now Jiska will continue to tell you more about emergency SOS.
So a bit more about how emergency SOS works under the hood. First of all, you call emergency services, and when that fails in your phone, you would see a new button. So this is not really intuitive to use. Some people might not even try to call emergency services if they see they have low reception, but whatever. When this happens, then they can initiate this emergency texting. So it's a little bit hidden and not in the standard UI. And even if you would bypass that, so we had a previous talk on that, you cannot just initiate this. You need to set several hooks to get there if you're not doing an actual emergency call. And then you would send a lot of information. So first you put in some questionnaire where you answer several questions in a very compressed format to efficiently tell the emergency services what kind of help you need. And then, next part is you can initialize text messages, and your medical ID will be sent. Something super important is that they also send your battery state in just 2-bit, so they have 4 battery states, more than 60%, or the other 60, 30, 10%, so that if at some point you stop messaging, the first responders would know this. And these 2 bits are also sent in every message, so that keeps them updated about your current state. And another thing is location updates. So depending on how much you move and so on, but every few minutes, there will be another message in the background where they just send your current location while your emergency call or emergency texting session is open. If you're inactive for 2 hours, the session will be closed, but otherwise, even if you disconnect and reconnect, your emergency session is still the same and just updates this information whenever you are connected. They have a very special text compression, which we also measured a bit. So while you're online, your phone would download so-called compression codecs, which are language-specific for all the languages that you have set on your phone. So not all supported languages, but on my phone, it was just English and German being downloaded, and it would try to compress your text with this language compression codecs, and if they compress, then they would use that codec, otherwise they don't. So if you just write something like la 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 la, which is not in any dictionary, they wouldn't use the compression codec. We tried generating a bunch of messages using ChatGPT, like best tool for texting, and tried how well the compression works. For rather short messages like this have like 35 characters on average, the compression is like down to 12 characters, but it really depends on your message length and how well the text that you write compress. And they are using like they are not using 7-bit ASCII, but like they use like a full byte per character. So maybe they could save more with just supporting less characters, but whatever. This is what they do. And Roadside Assistant is pretty much the same tech stack. So it's just different UI, but technologically just the same thing. Now, what are our reverse engineering options? So most things we just reverse engineered with a rather passive setup, where the most important part was this sector for the communication going on between the iPhone and the baseband. You can access this with a so-called baseband debug profile, so you install that to a phone which can be non-jailbroken, and then you would see all the messages exchanged between your phone and the baseband. Of course, the baseband then is sending or modulating a waveform at some point, which is not one-to-one the same thing that is happening in the QMI messages, so there's some more abstraction to this. But the cool part about QMI is we see what the modem is instructed to do and what is then received as a reply after decoding. And from this, we gained some insights into how this whole satellite communication works. So we have the like some iOS processors and the baseband, and they talk to each other over QMI. They start with some orientation updates and a target and general config list. This is meant to be like you're somewhere on Earth with some location, and you want to point at a satellite, and the problem is that the phone does not have any accelerator to the baseband chip itself doesn't know in which orientation your phone is and where you are, so this all needs to be sent to the baseband chip in order to help you pointing correctly and setting the beamforming and stuff on the phone itself. So this is general config going there that only has to do with the whole thing of you pointing the phone towards the satellite. Next part is some activation step where the chip gets secrets from you. So these are the LLC identifier, which is just a hash of the public key, so that Apple knows about the key that you previously exchanged with them while being online, what Alex just explained for Find My. And also the shared secret is sent to the baseband, which is the result from this offline Diffie-Hellman key exchange. So with these two things, the phone then connects to the satellite, and also at the point where the keys are being used, they're already being deactivated. So there's like these 30 LSC keys, and except from the last restored key, the key is just going to be deleted after this activation step. Then, if everything goes well, the satellite will send you back that you have a connection established, and then you initialize something that's called a registration, and now, depending on what you had in the activation, like if the keys were valid or not, you will get a security config usage. Otherwise, you might also get something like that there's an update needed and so on. So if you experiment with invalid keys, that might get you to different messages. But so this is what happens on success. You will get a security config usage with some more security information for the whole connection. And then you do the actual message transmission, which can be a Find My message, but it could also be multiple emergency messages. And then their reception is confirmed by the satellite, hopefully at some point, and you will get like progress and confirmation. For emergency texting, you would also get messages back from the first responders. And after all of this is done, you disconnect. For the case of Find My, you really just send that one single Find My message and disconnect, I guess to save battery power, and because you can just send Find My message every 15 minutes. And this is a lot of passive observation that you can do, but for some things you need a real phone, like an iPhone 14. On that you can tamper with some settings to see what happens in a real network. And we only had an iPhone 13 mini security research device at that point in time, and there was like no iOS 16 jailbreak. But luckily we got an SRD and could try a couple of these things. So it's a bit different from a jailbroken phone, but we could still hook stuff with Frida. And try out a couple of ideas that we had before. And with this, I'm handing over to Alex to show you what we tried.
Yeah, so we already had the idea to do free satellite messaging, even though Apple hadn't announced it with iOS 18 back then. But our idea was, okay, we want to have free satellite messaging on an iPhone 14, which has no jailbreak, because there was no jailbreak available. We needed to do some tricks maybe to get our message sent just over the Find My location sharing. Why did we want to have check if that's possible? Because now the satellite messages, they are expensive. Apple always says they are free for 2 years, and then they extend the 2 years for another 2 years. But we don't know if they will charge for it at some point. But at least satellite communication cannot be free forever, so we thought maybe we can do it for free. So what was our initial idea? We thought, okay, there's like so many GPS locations you can have, and they are basically in this format of you just have like a float number that is shared, and in the data that's actually shared, we have 10 digits for each position, for the position for latitude and longitude each, and that would allow us to send 8 bytes of data, just encoded in an actual GPS location. So we thought like, okay, let's map an alphabet on this, on the coordinates, so we can have some characters. We have our 10-digit space, so that would allow us to have like 2 digits, could map on 1 character, and in the end, like a hello world message should be possible. So we had the idea, okay, let's go take an iPhone 14 that is just a regular device, put in the fake location with Xcode or some developer tools, and then just start location sharing over satellite in the idea that maybe the baseband gets the actual location so we can actually connect to the satellite, but then the process that actually shares the location takes our fake location. Yeah, but Apple was a bit smarter here, because obviously, when you use fake locations with Xcode, the device knows that, and some system processes, they just don't process that fake location. Same here, and even if you try doing that, then Apple or the device will start to lock you out of satellite communication entirely for a few days. So then I thought, like, okay, maybe, I don't know, it just came newly, so maybe it has been turned off because there's a bug or something. But with Jiska's phone, everything was working fine, so I was a bit confused. Okay, after 2 days, everything was working again, and I also saw in the logs that there's like something, a blocking mode or something, because I always reach this part, but never connected to the satellite. Yeah, but then the jailbreak came, and our research device arrived, and we had the idea, okay, but in the end, this actual satellite message with your location data contains 82 bytes. So in this 82 bytes, it's just a tiny little bit of location, and the rest is just encryption. So there's an ephemeral public key that has to be sent, that takes a lot of bytes, and an authentication tag in the end. And since everything is somehow encrypted or contains data that looks kind of random, we thought maybe Apple doesn't know if we replace this whole set of bytes with our own message. And then we found out, okay, we could even send more bytes than just 83. We could send up to 160 bytes. So this was actually working. We were just replacing the location message with our custom message. But Apple was a bit, we reported this, and now they limited us back to 82 bytes. but it actually still works. And in the end, when you want to receive a message, because the Find My location sharing only works one way, you can only share but not receive locations over satellite, you need an internet connection. But at least you can send some messages to your friends. And we have also made a demo app. Here it's still called Satellite Send. So it's designed like a messenger. You share. Jiska has made some awesome hooks in there that just connect immediately to the satellite API and start sharing the message, but it actually still says something about your location is being shared in a minute. And Jiska has more details on this.
Yes, let's wait for a few seconds. Now it's just saying like it's sending your location, but like triggered via our messaging app. So you see it's still, the phone still thinks there is a location being shared over Find My, but for real it's other data. All right, should be sent in a few seconds. I do these things on my balcony at home and then it always takes a little bit. All right. So how does this work? Apple has a ton of private APIs that they don't expose to regular apps, but that you can actually include in your app and use when you're jailbroken. So this thing would never make it through app review, but you can use a private API. You also need a special entitlement that usually only Apple's binaries would get, and then you can call into this SP owner framework. SP owner is for search party, because search party daemon is the thing that does like Find My location sharing. And there is two important functions here. One of them is you can call, hey, I want to publish my current location, which is triggering the dialog. And then I'm using a second method, which is also super important here for seeing what the status is, because for some reasons, like it might be that you're currently still connected to Wi-Fi and you are not even allowed to send location or share location over satellite, and then you would get error messages back from the API, and that's why I just subscribe to the status and then update the message bubble from gray to blue if it was actually sent. So this is one part of the API, but this can only allow you to share a location. So triggering this does nothing with messaging, and for messaging you need to get even further and hook into the search party daemon itself. So my idea was, what is like the dirtiest way of doing this? Well, I just write into a file that the search party daemon can read from my app. So this is just a shared folder, or like not really shared folder, but a folder being used by the search party daemon and accessible by the search party daemon that my app writes to. And then I set something that's called a tweak. So with DOS, you can program tweaks on jailbroken phones, similar to Frida, but it just always runs in the background and hooks this CT Find My message function when a message is sent to replace the location with the text that is in that file. So these are the two parts that you need for sending arbitrary text messages, and that's just sending. We also want to receive messages, and that's what Alex implemented.
Yeah. So to receive messages, your phone needs to access a lot of different keys and files that also are used by the Find My app. But in the end, all this just needs to be done to send one request to Apple's server. So you send basically the same request that I was showing before that would trigger live location updates, but you can set it to just shallow, and then it will send the last location update that Apple has stored. So it's in some Apple domain, Find My service fetch, and what you need to send to Apple is a FMID, so a Find My ID, of the user of whom you want to have the location, and the Find My ID basically is the Apple ID of the user, and the Apple ID is not the email address, it's a number that is just a fixed number assigned to each Apple ID. And then you have the location ID, which is for each location sharing session, there's one location ID. So this is sent to Apple server. Apple server then responds if you are actually sharing with that person, the location timestamp, the location, and a format And in this case, if the format is set to 1, it's a satellite location update. And the location in our case, it will always be base64 encoded data, but since we just send text instead of an encrypted location format, we can always just decode it with UTF-8. At the moment, it's not encrypted and somehow, but it's just a demo. So in the end, then you will receive the message, and it's a satellite message. So what you can see here, this is a message sent from Semo. This is not fake, it's an actual satellite message that we send. And I just changed the email address. Yeah, how do you get, I want to get into some details, how do you get actually this Find My ID and Location ID, because there's a lot of things you need to access. You need to have authorization to the Apple server, you need to have third-party tokens for iCloud and so on, but you also need to have this data about your friend you're sharing your location with. Cool thing is we also did some research in Find My before about Tercas and AirTags, and we found out that there are some folders on the system that sound interesting. For example, in this case, it's a secure location shared key. Secure location is the name for sharing location with friends over Find My. And in that folder, we can find a file which is called .record. It's just a plist, so it's just an XML file that has 3 entries, and that entries are a nonce attack and some encrypted data. And now we just need to decrypt it. How do we decrypt it? There's a key that's just stored on your iPhone. It's called beacon store key, and you can use that key and just some simple AES to decrypt this data. And then in the end, you will also get a new plist out there that contains all the data you will need to receive the location. So there are other interesting record files. I will do a short detour here, because what can we also find? We can find a lot of things that has named Beacon. Beacon, that's all your devices that are in the Find My network. So the Find My network is this like offline finding function. When your iPhone is lost, doesn't have any connection, say you're on a connection or something, you can still find it because it's sending these Bluetooth beacons out there. AirTags work exactly the same way, and now there's lots of devices that are also supported, which are third-party devices since they collaborate with Apple, so you can purchase third-party tags and so on. In the own beacons, you find all the information you need to get their location. In the beacon naming record, you find the name, and the beacon estimated location is like the last location of that. And then the last files we found, there are safe locations, so there's also location data about you stored there. Safe locations are the locations that you have marked as safe, so you can leave your keys at home, for example, and your iPhone wouldn't send you a message, hey, you lost your keys at home, please go back. But also office locations and like all the locations where people have marked, where you can say, okay, this is a location where I don't need to be annoyed by my phone that I left my laptop there or so. And then there's a secure location label. These are the locations where you want to be notified when one of your friends is getting there, because there is not just the location sharing feature, you also have this feature where your friends can set, okay, I want to get a notification when my friend gets home, so home location would also be in there, and your iPhone would just recognize. Why am I telling you all of this? It's a bit of our other research, not 100% relate to satellite besides receiving messages, but we found CVE in here, so a vulnerability, and the vulnerability is not really complicated, but the outcome is rather big. So what we found is that this beacon store key, you can just request any key entry from your keychain on your Mac, and it should ask you for your Mac password, because then it says, yeah, this app wants to access this key, do you want to give it to it? But in that case, it was not asking for a password, because you can always request the metadata of each key. And in the metadata, there was a mistake, because here you can see the key is in 2 places. It's in the vData, which is the actual securely stored data, and then it's also in the general attribute, which is attribute that you can use to describe your key. So any app that was running on your Mac could just send to the keychain, hey, please give me this key. It would get the key entry, but not the actual key back, but the key was stored in a general attribute, so it could just get all these files from your system and decrypt them. What could this app do? We have made a long time ago an app called OpenHaystack, which can be used to find things over Find My, and I just modified it to find all my devices. And in this case, yeah, you can see all my devices, they are hanging around in Halle 2 here. So yeah, it's a pretty big impact, even though the actual issue here was not really big, hard buffer overflow that had to be exploited. But Apple has fixed this in the recent update, so 14.5, 17.5 are safe. The general attribute is empty again, and the key is asking for your Mac password when you're trying to request it. Yeah, and now Jiska will tell you more about how we bypass some restrictions.
So yeah, this is what we promised you to be in the talk, and the new content on how to break some of the barriers. When we got our research devices, we were kind of shocked because we got a Korean security research device. So Korean means in your model number, there is a 2-letter part that determines in which country it was produced, and that might lock down some features. Especially in Korea, Find My Friends is not allowed, so you can not share your location or your friend's location in Korea. And so we could not set this up on the phone. But at the point in time, we were on iOS 17, and the only feature that we can use without using any emergency services is the Find My Friends location sharing. So we couldn't use it for what we wanted, and had a challenge of hacking through the restrictions. And so we were like, okay, what we want is like maybe in an American SRD, that would be LL or something as country code. So there's different country codes, not necessarily what you would associate with it, but you can just think of wishing for another country code. So what did we do? We changed it. To change it, there is one really helpful file that is also being used a lot by jailbreakers. So there is libmobile Gestalt, and this library holds a lot of the properties of your phone. And it is being cached in a plist file, so certain properties are received at some point and then cached into the file for not being retrieved from the hardware for real. And you can edit this file. So when you would do like a full reset of the phone, then it would also reset that cache, but otherwise you can override it and it would keep that. But another issue with changing the model number like this is that it wouldn't update. So even if you edit the file, you don't see it, and you need to erase all content and settings. So not a full reset of the phone, just erasing the contents and settings. And once you do that and go through the process and relog into your account, you can use the Find My Friends feature on a security research device. So this is something you can, of course, not do on a non-jailbroken phone in any way. And you can also not do this with certain security bypasses. So, for example, Kawabanga allowed you to overwrite a file in memory, but you would not have it reboot persistent. And if you would reboot the phone or like go through this erase all contents and settings part, then Kawabanga wouldn't be active anymore. So you cannot use arbitrary bypasses for this, but you really need to go through this erase contents and settings. And so not possible with all setups that you can imagine. And another thing where this would not work is if you actually have a Korean Apple ID and created it on that phone, then it doesn't work. That's something that Alex tried in the very beginning. So I said, like, I found a bypass. Here's like my notes. Can you try to reproduce? And he was like, it doesn't work for me. And he actually created a new Apple ID on his new security research device, which while it was set to Korean, and so when he logged in already in some of his iCloud settings, apparently it just said like he has a Korean device account and cannot use it. So this bypass will likely not work for Korean people, but only for people who had at some point created an Apple ID on a non-Korean device. And with that, there is even more regional restrictions. So Apple just rolled out those services country by country, starting in iOS 16.1 with the US and Canada. Germany was added in iOS 16.2, lucky for us, so we could test stuff early on. But some other countries followed later, and there might even be more countries to follow. Here's again the map, and you can see the colored countries that have support, and it doesn't really match with the ground stations that you see, and you can also draw a coverage map based on the orbiting satellites combined with the ground stations, and that's also something that Globalstar, which is the network operator, provides. So they have coverage maps, and so just look here, we do not have Poland covered by Apple, but Poland is covered on the Globalstar map, so it should be working somehow, right? I mean, their services are offered in Poland, at least theoretically, and for me, living in Potsdam, it's not so far going there, so always worth a visit. From our previous talks, you might know that there is some configurations configuring what is allowed in your country, and which countries have satellite services. And that is, of course, something that we can override. So I was like, okay, sounds like a weekend trip. I eat some pierogi and also change the country code from Germany to Poland and just see what happens. So what would you guess? Well, a bit of detour here, like I made the mistake of not setting my iPhone as primary location sharing device before crossing the border, and then I was having issues with setting this up again, so that would have needed more hooks. So I was like driving over the border and then back to set up my phone, and then back to the border again to see if it works or not. A bit chaotic, but I mean, that's how you spend your weekend as a wireless security researcher on a German-Polish border. And at some point I was like, okay, now I can share my location over Find My, and you can see I have a position marked like somewhere close to the border, and now you might say, okay, are you sure, Jiska, that this was actually being sent from Poland? Did your phone think it was in Poland or not? And there's a couple of daemons on the device, I think like country daemon and so on. They figure out where you are also based on not just like GPS location, but also the cell towers that you see and the country code that they have. So I might have received maybe a cell tower from Germany or something and have the wrong location. But what gives us insight into this is with the Wireshark detector, we can see what my phone is actually sending to the satellite and what it is claiming at that point as location. So I just double-checked, and it was claiming that it is in Poland, but I could still establish the connection. So here we are, testing all those things. There is still one more barrier where I said like, okay, this is super annoying. So when you send your message from somewhere, it would say like, send again in 15 minutes. I'm like, 15 minutes, it's just way too long. And I found that setting to be in another property list of the search party daemon, where it just stores when the last location was sent. This is again something that you can only edit on a jailbroken device, like you cannot do this on a regular device, but when you edit this or hook it with Frida, like reading the property and restart the daemon so that they would read the property again, then you can send it more often. So you can just set it to null or just remove the property entirely, which is the state for when you have never sent a Find My message before. And you can send the next message. So you can successfully send more messages than every 15 minutes. Editing by hand, of course, I had multiple minutes in between sending, but like 1 or 2 minutes in between and not like 15 minutes. And that was super helpful for testing some features, also for making some recordings to not have to wait 15 minutes every time. Some disclaimer, so I mean, maybe you see this and you say like, I want to bypass this on my own, but when you get the LLC keys, then Apple also knows your Apple ID. That's how they can associate your location shared over Find My with your actually Find My ID. And that means Apple could track you down for doing this. They might block your Apple ID. They didn't do during our experiments, but I can imagine like if more people start abusing this and especially hook some stuff for the bypasses, that might happen. But still, I mean, you can bypass, it's all implemented in software. And then we had our satellite messenger, but iOS 18 came, right? And then so we were watching the WWDC keynote, we're like, okay, messages via satellite. I mean, we had that before, but like it's coming in iOS 18. It has some restrictions, so like, I mean, iMessage SMS over satellite is cool, but it's a US-only feature, and I guess it's not coming to Europe anytime soon. Like Apple stopped rolling out all the cool features to Germany or the European Union in general for the Digital Markets Act. So effectively, anything that is a cool feature but uses an API that cannot be used by third-party apps is just not coming. So. Super sad for us, but might be a motivation for using maybe our satellite messenger. And I mean, it was first, it is free, so it's probably a good alternative. So even though we were a bit like disappointed by how all of this turned out, we wanted to look into how does it work, like how does iOS 18 implement this, and there's a couple of things being updated. So in the very first beta that was released like 2 weeks ago or so, they changed a couple of things. So there's Com Center, which is the daemon handling baseband stuff, has new message types being added. So the first ones you can see is like this whole emergency texting and Find My stuff and roadside. But they have a new thing that's called like Carrier Pigeon iMessage Lite. So this is the iMessage feature. They also have something called Set SMS, so this is the satellite SMS feature. So it's all there already. And they also have feature flags relating to those names, but those feature flags are in identity services, IDS, just a different daemon because messaging and key exchange for messaging is implemented there. Interestingly, also, like if you are on that beta and and have satellite services enabled, you would get a new config plist, and you can notice here we do have a couple of new services. So we have emergency and Find My roadside for the US, but we also have new features in the US, which are iMessage Lite and Set SMS. And well, there is one trick that you might remember. So this time we just say, whatever, we are Germans and we want to use those features. And yes, it works. So this is me messaging with Christine. So Christine was so kind and she updated her, like she has a test device that she also updated to the latest iOS beta, and she is located in the US. So that makes sure that there is no restrictions or anything, and so we were actually texting here, and she allowed me to share the picture of her cute dog, Honey, but then you see how the normal iMessages are switched to satellite, and this is actually me next to like the Troopers hotel texting and trying out those things. So yay, it works. Even in Europe, so it's just a software restriction again. Some notes on this, so under the hood, you do have a key exchange going on in the identity services daemon, and that is just supported if also your communication partner is on iOS 18 and has everything correctly set up. And by default, when your contact has iMessage, like it would always try to contact the other person over iMessage and not with the satellite SMS feature. So satellite SMS is really just a fallback. And from how I understood it, what happens is that your phone would send an SMS over satellite to your own network operator, which then in turn makes an SMS from it and send it to somewhere. So that means that your network provider needs to support receiving those messages from Apple and forwarding in both directions to actually have SMS service. And you can also see this message here, like I'm using I also tried getting different SIM, and then I got an eSIM, and that was Austrian or something, and it just said still like your network provider does just not support this feature yet. So it just wouldn't send it. So there's probably some hooks to get around this, but then still like if your network provider doesn't support the forwarding, where is the point in sending SMS to Apple server? It's probably just getting stuck somewhere. So maybe that teases you into updating your iPhone to iOS 18, but only in the US, not in Germany. So if you're in Germany, we have something for you, which is a release of our satellite messenger. Please note, it does not have any bypasses for restrictions. So this is really just the whole thing of replacing a Find My message with an arbitrary text message on a jailbroken phone. So you still have all the country restrictions, the 15-minute limit and everything. It's just a service on top of this. And it's online, so you can get it here.
And if you wonder about the totally cool slide we made here, we called this satellite messenger Saftelite, and the idea behind that was there's like some service called SFT, like some packages are marked with SFT that are handling satellite messages, and we were always like, what is SFT? It's probably Saftelite. And
Alex asked me, I think, a few months ago, what does SFT stand for? Which was like Saftelite, obviously.
Yeah.
So we were like, okay, that's a Saftelite messenger. And so with this, we do have a little bit of time for Q&A. We also have some social media if you want to follow us.
All right, thank you very much for the great talk. Are there questions? And I believe there are.
I could just start with one because I have one. Did you also already look into the radio side of this? So what is actually transmitted over the air, decoding that?
Yes, but unfinished, so not on the slides.
Okay.
Work in progress.
Looking forward to that. Any other questions?
Hello, thanks for the talk. When there is an emergency SOS, where is the PSAP or the emergency center? Do you know if in which country and how they communicate with the local firemen or whatever?
So from how I understood it, I mean, I don't have any access to the backend, so it's like some stuff I'm just guessing, but like, so Apple gives you a separate encryption key for those messages. And I think Apple knows the encryption key and can decrypt the emergency texting messages locally, like on their servers. And so they act as like middleman for then forwarding the emergency messages to some emergency center. Probably they just have like very few. I mean, they can then dispatch this again to someone who is nearby. So I don't think that like every little first responder center or something has like satellite connectivity features, so it's just like some people then dispatching again, which is totally sufficient. I guess how many emergency calls are there where people really need satellite services? There's a few instances, like when there were like the wildfires in Hawaii, where like some people use that and also publicly talked about it, but I guess in most cases when you have no cellular coverage, you hopefully don't have an accident, and even then, like, it's really just a few per week, I hope.
Thanks.
More questions?
Yeah, we saw in the demo that it took quite long to transmit the message. How long is the actual message in total? Just yes.
So the reason why it takes long in the demo videos is that I hate going outside, so I just sit at home at my table and have the windows next to me, and so if I would actually step out on the balcony, it works much faster. So you don't really notice that it takes super long when you're like the iMessage feature and stuff. It is more smoothly.
Yeah, but the maximum length is 160 bytes. Like that's now has been limited further by Apple for the Find My message, but there we were able to try out byte by byte. When do we reach a level where the satellite just doesn't acknowledge our message? Yeah.
Yeah, and maybe to add to this, so if you're using iMessage over satellite, you can also not send any photos. So also Christine, I guess she wanted to send me more pics of honey and was like, oh, I cannot send you any pictures. Imagine how many messages you need to send dog photos in 160 bytes.
All right, so if there are no questions anymore, then we would like to prepare the stage for the next talk. Thanks for attending, and thanks again for the great talk.
Thank you.
Thank you.